So today we're going to talk about quadratic systems. We're going to be able to solve and graph systems of linear and quadratic equations. When you're solving a system of equations, what are you solving for? So when two graphs are graphed on the same coordinate plane, we're looking for the point of intersection, where those two graphs intersect. If you have a system of a linear function and a quadratic, how many solutions will you have? So here we have three examples. In the first example, the parabola and the line are crossing each other at two spots. So that means that they have two solutions. They have 2 points of intersection. When you have one solution or 1 point of intersection, they're only touching at 1 point. And when they don't intersect at all, there is no solution. So what was the first method that you learned how to solve systems of equations with? So we didn't do it in here, but the way that you learned when you first learned systems would be through graphing. Now graphing is kind of a pain. We don't like to graph because of it's when we're counting, it might not be exact numbers, and especially our graph that we have, it's going to be a little bit difficult to find the point of intersection. You're going to have to keep continuing to draw the graph all the way. So let's just look through graphing what this intersection looks like. So we have two functions. We have a quadratic and we have a linear. So if we take that quadratic function and we try to graph it, we can find the vertex by doing negative b over 2a, which is going to be negative 6 over 2 times 1. So negative 6 over 2. We get negative 3 for x. So that's the x value of the vertex. Now we plug it in to find the y. So y equals negative 3 squared plus 6 times negative 3 plus 9. Okay, and when we solve that, we end up getting 0. If we try to factor it, we can find our x-intercepts. So multiplies to 9 and adds to 6. We can use 3 and 3. So x plus 3 and x plus 3. But that's not really going to help us, since if we set them to 0, we end up with x equals negative 3, which is the same as our vertex. So let's make an xy chart. So I'm going to pick values of x. So I'm going to pick negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, and 0, just to have a look at what this is going to look like, because I need to have some points that are to the left of my vertex and some points to the right of my vertex. The corresponding y's, so when I plug in negative 6, I get 9. With negative 5, I get 4. With negative 4, I get 1. With negative 3, I get 0. Negative 2, I get 1. Negative 1, I get 4. And 0, I get 9. So if I go to graph this, I have negative 6, negative 9. I have negative 5 and 4. I have negative 4, 1. Negative 3, 0. Negative 2, 1. Negative 1, 4. 0, 9. So I connect my points. I have my parabola. Now to graph y equals x plus 3, you could also make an xy chart if you want. You can graph this just because it's a linear, so you start with the y-intercept, which is 3. So I go to 3, and I put a dot at 3. I know that my slope is 1, because it's in front of the x, I have a 1. So I can count up 1 over 1, up 1 over 1. I can also go down 1 and to the left 1, down 1 and to the left 1, down 1 and to the left 1. So I can see where they're intersecting, and they're actually intersecting at 2 spots. They're intersecting here and here. I'll make that a different color so you can see. The red dots are where they intersect. So they're intersecting at negative 3, 0 and at negative 2, 1. So there's 2 points of intersection. It's pretty annoying to have to graph it, so we can use substitution. When you're using substitution, you're just going to set the two equations equal to each other and solve accordingly. So since they're both equal to y, I could take this x plus 5 and plug it into the y in the other equation. So I'm basically just setting the two equal to each other. So x plus 5 equals negative x squared minus 3x plus 10. So in order to solve this, we have to set it to 0. So I like my x squareds to be positive, so I'm actually going to move everything from the right side to the left side. So I'm going to add over the x squared, I'm going to add the 3x, and I'm going to subtract the 10. So my right-hand side is just 0. And on the left-hand side, I have x squared plus 4x minus 5. So this new equation, I'm going to factor it. So it multiplies to negative 5, adds to 4. So I can use x minus 1 and x plus 5 equals 0. And I'm going to solve each one. So I get x equals 1, and I get x equals negative 5. So since it's a solution of a system, that means that the solution is going to be a point. So right now we only have our x values. We need to find the corresponding y values. So take either of the two original equations. So I'm going to take the one that's easier. I'm going to take y equals x plus 5, and I'm going to plug it in. So if x equals 1, y is going to be equal to 1 plus 5, which is going to be 6. And then if I take the second one I got, when x equals negative 5, I'm going to plug that in, y equals negative 5 plus 5, which gives me 0. So my two solutions here would be 1/6 and negative 5, 0. Okay, so now we have two quadratic equations, but we're going to do the same exact method. We know what y equals, so we could take one and plug it in for y. So we're setting the two equations equal to each other. Okay, first thing we want to do is make sure that we bring everything to one side. So I'm going to move my negative x squared and my 5. I'm going to add x squared and subtract 5. So I end up with 0 equals 2x squared minus 4x, and the 5's are going to cancel out. So from here, I want to see if I can factor. So I can take out a GCF, which is 2x, and I'm left with x minus 2, and I'm setting it equal to 0. So I'm going to set 2x equal to 0, and I'll get x is 0. And then x minus 2 equals 0, x equals 2. So now I have to find the corresponding y values. So when x equals 0, you can plug it into any of the two equations. So I'm going to plug it into the bottom one. So I'm going to say y equals negative 0 squared plus 5. So y equals 5. And in the second one, when x equals 2, y is going to be negative 2 squared plus 5. So that's going to be negative 4 plus 5. So y equals 1. So our two solutions then would be 0, 5 and 2, 1. Okay, so here we have another one. Again, set them equal to each other. So I'm going to take this and plug it in for y. So negative x squared minus 5 equals x squared minus 4x plus 5. Okay, so I'm going to add the x squared and I'm going to add the 5, add the x squared, add the 5. So this looks very similar to the problem that we just did. However, now we don't have a subtracting 5, so we're not canceling out our 5's on the right side. So we end up with 2x squared minus 4x plus 10 equals 0. Okay, so first thing we want to do is try to take out a GCF. So we could take out a 2. So we have x squared minus 2x plus 5 equals 0. And we can divide that 2 out. So we end up with just x squared minus 2x plus 5 equals 0. Okay, next we want to try to factor it. So multiplies to 5, adds to negative 2. Nothing's going to work. So since nothing's going to work, we have to use the quadratic formula. So we're going to say x equals negative b, which is 2, plus or minus the square root of negative 2 squared minus 4 times 1 times 5, all over 2 times 1. So we get 2 plus or minus the square root of 4 minus 20 over 2. So we get 2 plus or minus the square root of negative 16 over 2. So I can take out the I from the negative 16, and the square root of 16 is 4. So I could rewrite that as 4i, and then everything can be divided by 2. So I have 1 plus or minus 2i. Since I have an I in my answer, I can't actually get a real answer. So that means that this has no solution. So this would be one where these two parabolas don't intersect at all. Okay, so you can have no solution if you end up with an I in your answer.